Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome you all the students of class 11 for our chemistry lecture as we have started the chapter that is elements of group 1 and 2. This is our fifth lecture for the same. In our previous lecture we have studied chemical properties of elements of group 1 and 2. Today we are moving forward towards the same. Today we are going to study the chemical properties in terms of reducing nature of elements of group 1 and 2. First, group 1. The reducing power of an element of group 1 and 2. It is measured in terms of standard electrode potential. Whatever the reducing power is there of the elements of group 1, it is measured in terms of the standard electrode potential. Remember students, standard electrode potential is used to measure the reducing power of an elements of group 1. Corresponding to the transformation, here the elements, as we know, group 1 elements, they liberate an electron, they donate an electron. Okay, so your metal is there. M means it is your metal. When it gives one electron, here you see M in bracket S has been written. It means it is in solid in state. Fine. M solid in state. When it gives an electron, it get converted into M plus. AQ means aqueous in state, that is your liquid. Okay, so when an elements, that is your group 1 element is your alkali metal. Okay, so that is why here it has been written M. So here group 1 element, any of the element of group 1, when it liberate an electron, it get converted into cation. Your positive charge is nothing but your cations. So here all the alkali metal of group 1, they have high negative value of standard electrode potential. When all the elements of group 1, that is your alkali metal, have high negative value of standard electrode potential, which indicate their strong reducing nature. Obviously, if the standard electron potential value is high, that particular elements will be having strong reducing nature. So here in group 1, lithium is the most powerful and sodium the least powerful in the group. Lithium is the most powerful reducing element, while sodium is the least powerful reducing element. We have studied table 8.4 in that the value of the reducing power of the elements have been given. So here student, remember the reducing power is measured in terms of standard electrode potential. Here an element liberate an electron and get converted into cations. The elements having high negative value of standard electron potential will be more or strong reducing nature. In the group 1, lithium is the most powerful and sodium is the least powerful. Understood student? Let's move forward towards the group 2. Here the group 2 element is your alkaline earth metal. They have high negative value of standard reduction potential. Fine. As they are having the high value of negative standard electrode potential, this value has been given in table 8.5. In a previous lecture we have studied table 8.4 and 8.5. So they will be strong reducing agent. As the standard reduction potential value will be high negative, they will be strong reducing agent. However, their reducing power is less than that of alkali metal. Your alkali metal, that is your group 1, is more reducing in nature as compared to group 2. They are also having the reducing power, but as compared to alkali metal, they will be little bit lesser. Okay, student? Let's move towards the next chemical property. Solution in liquid ammonia. Liquid ammonia. Ammonia is your NH3. Here for group 1, the alkali metal, they are soluble in liquid ammonia. When we are adding alkali metal, that is a group 1 element in liquid ammonia, they give deep blue color. Deep blue color. The color will be changed to deep blue. Okay. Solution, we show electrical conductivity. What do you mean by electrical conductivity? Where there will be electrical flow of electron will be there. Okay. When the electricity is produced, where there is a flow of electron will be there. So here, when alkali metal, they are soluble in liquid ammonia, they give deep blue color, which show electrical conductivity. Now here M is nothing but your any of the metal of group 1 when it is being treated with liquid ammonia NH3. Okay, it get converted into M NH3. Here your metal will liberate an electron. That electron will move towards the NH3. Your NH3, X or Y means it will be the number, how much amount we have taken. Okay, as some of the amount will move towards the metal and some of the amount will grabs an electron. Fine. So here, when any of the alkali metal will be reacted with liquid ammonia, metal will liberate an electron. Here some of the ammonia will combine with the metal and some will grabs an electron. The metal will form a complex M NH3 bracket close X to the cations, and your NH3 Y will grabs an electron and it gets converted into anions. So here the ammoniated electron is responsible for the deep blue color of this solution. Who will be responsible for the deep blue color? Here ammoniated, the ammonia, liquid ammonia which grabs an electron. They will be responsible for the deep blue color of this solution. These solutions are paramagnetic. Paramagnetic, diamagnetic, ferromagnetic, these are the various properties you have been studied in your 10th standard. Further in 11th and 12th, you are going to study this in detail. These solutions are paramagnetic and on standing liberate hydrogen slowly, resulting in the formation of the metal amide. We are going to see this, what is happening in the reaction. The deep blue color changes to bronze and the solution become diamagnetic. Here, student, your ammoniated electron, this is responsible for the formation of blue color of the solution, and these solution are paramagnetic in nature. Now, student, this solution on standing will liberate hydrogen. You see M plus ammoniated ammonia, that is your metal is linked with the ammonia, plus E minus ammoniated electron plus NH3. Now what is happening is here, student, your MNH2 AM. Your AM is nothing but your solution in ammonia, your metal which has been dipped in ammonia. Fine. So MNH2 plus H2. Here you see in the product hydrogen has been liberated. Hydrogen gas has been liberated. Fine. Which due to the liberation of hydrogen gas, it result in formation of the metal amide. What you see, MnH2 is nothing but it is a metal amide. Fine. And H2 has been liberated out, that is your hydrogen gas has been liberated out. So here the blue color changes to bronze. the blue color solution of the ammonia has been changed to bronze color, and the solution which is paramagnetic in nature earlier has changes to diamagnetic in nature. Let's move forward towards the group 2. Similarly, alkali metal, the alkaline earth metal are also soluble in liquid ammonia. How the alkali metal, when has been treated with liquid ammonia, they are soluble and gives deep blue color. Here also alkaline earth metal, they are also soluble in liquid ammonia and which gives deep blue black color solution. Right? Now here you see M plus X plus 2Y NH3. When any of the metal of alkaline earth metal will be treated with liquid ammonia, it get converted into metal cations complex and your ammonia anions. Okay, here your ammonia will grabs an electron, some of the ammonia will grabs an electron, and some of the ammonia will link with the metal and get converted into metal complex. So here student, we have completed with the chemical properties of the elements. Now we are moving towards the uses of group 1 and group 2. There are various uses which has been given in your textbook. You are supposed to study some of the few. First uses, lithium metal is used in long life batteries. Where batteries which we are using in our day-to-day life, lithium metal is used. It is used in digital watches, the watches which we are using, the calculator and computer. We are using batteries, digital watches, calculator, computer. These are day-to-day life. Okay, they are linked with the day-to-day life. So in these things, lithium metal is being used. Liquid sodium. It has been used for heat transfer in nuclear power station. When nuclear power station is there we are using liquid sodium for heat transfer. Okay, potassium chloride, that is a KCl. It is used as a fertilizer. Potassium is used in manufacturing of potassium superoxide for oxygen generator, as it is good absorbent of carbon dioxide. These are the various uses. While cesium is used in photoelectric cell. So yes student, these are some of the uses which has been given for group 1. In this, you are supposed to study some of them. Now, uses of group 2. Beryllium. It is used as a moderator in nuclear reactor. We are doing nuclear reaction, in that beryllium is used as a moderator in nuclear reactor. Alloy of magnesium and aluminium. What is the alloy? It is combination of two or more metal. Fine. When we combine two metal, it gives an alloy. So here alloy of magnesium and aluminium is used as structural material in aircraft, your aeroplane, helicopter. So this alloy, magnesium and aluminium alloy, is used as a structural material in aircraft. Calcium ions are important ingredient in biological system. As we know, calcium is an essential for healthy growth of bones and teeth. We require calcium for our healthy growth of bones and teeth. Barium sulfate, BaSO4. It is used in medicine as barium meal for intestinal x-rays. Okay, in medicinal purpose we are using barium sulfate. Here element radium. It is used in radiotherapy for cancer treatment. Okay, the cancer treatment person is being using radiotherapy in which radium is used. So here these are the various uses of group 2 elements. So student, we have studied today chemical properties of group 1 and group 2 elements, and we have studied uses of group 1 and group 2 elements. Study it well. Hope you have understood. Till then, take care. Study well. Do your best. Thank you, student.